Sure. Thank you very much, Doctor. Assalamualaikum and good afternoon, everyone. My name is Amshah Faiz, Business Development Director for Ofotech, Sendirian Berhad. Before anything, I would like to thank the team at UM for this kind invitation to present a lecture on the topic of advancement in surveying using unmanned aerial vehicles, VR and AR. Basically, for those of you who do not know, Ofotech is a startup company, a multi-award winning technology innovations company. We specialize in IR 4.0 technologies, including but not limited to drones, remote sensing, big data, augmented reality, and even industrial IoT technology. My purpose for today is just to share with you more on the industrial side or the real world applications using UAS, VR, and AR tools. So we will be looking into this topic in the context of industry 4.0, specifically in commercial sector applications. So I guess in the next, we will treat this session like kind of casual, not too formal. In the next 20 minutes, we will be covering the basic fundamentals of the three technology platforms before moving into the fun part, which is the live demo and the sector application relevant to your courses. Presentation will gravitate towards this area, this field, GeoAI, which will have relevance to the topic that you are currently discussing. So just to introduce you for the first technology in IR 4.0, UAVs, AR and VR. So I will give you the structure of the presentation as you see in front of the screen, just a basic introduction. What are they? The technologies involved, the definition, the history, the case-specific applications, and then a demo. And then we will move to the conclusion and Q&A. As mentioned, if there are questions, if I'm going too fast or anything, do feel free to stop me. I'll be happy to repeat myself. So for the next slide. So UAVs, unmanned aerial vehicle. Or drones, commonly referred to by the common layman. So basically this technology has been around since several decades already, I would say in 1980s. So I believe it was the Japanese who first invented the technology. In terms of remote controlled objects or vehicles, that was invented somewhere in the early 1900s. However, flying objects, helicopters or remote controlled aviation vehicles, UAVs, this pretty much was somewhere around 1980s, but pretty much not really involved in any commercial applications. You see, the technology was specifically or exclusive for military applications. When we talk about United States or the Western Europe, when we watch the news, it's quite typical seeing that drones in the areas of military reconnaissance and surveillance is a tool that is very heavily used. However, in the early 2016, 2010, regulatory frameworks or regulation revolving around commercial drone applications for civilian usage have been quite becoming lenient. So, for example, Poland, the Polish government in 2014 was the first government in the world to having refined a clear framework for drone application. United States also followed suit the same year with the Federal Aviation Administration also giving clear guidelines. And from that moment onwards, drones have become much more heavily penetrated in oil and gas and construction sectors. So gradually, as site workers and industrial owners, they saw the benefits that drones had to offer. Gradually, new use cases were introduced, being implemented in other sectors as well. So for 2016, there was a landmark report study by PwC, PricewaterhouseCoopers. So PwC is a prominent international consultancy firm. They do research on an annual basis, and they have determined back then that the industry, the drone-powered solutions, estimated 27 billion US dollars. So that's quite a big segment. So you notice on the right area, the number is breakdown into all the various sectors from infrastructure, mining, entertainment, insurance, and also the value for each respective segment. So notice that the benefits of drones are a lot. Effectively, the first one is it can eliminate the human risk factor. If we considered things like mining or oil and gas offshore, high explosives areas. So effectively, by sending drones to high places, areas hard to access, it eliminates the human risk factor. So this represents a big benefit. And another potential is also the timely execution, that is very effective and efficient in terms of both cost and timing. Companies saw it translating in their balance sheet, in that profits were being made, and also that the information and the work execution done by drones are highly accurate. So the combination of these values actually appealed to many industry owners, sector players. So effectively, more and more use cases are being developed. We are talking about currently, we're talking about environmental, we are talking about search and rescue. There are new use cases being implemented and discovered every day. So it's an exciting time, especially for this industry that we are currently in. So for the next slide, I just want you, however, to understand that at the end of the day, the drone is just a flying object, because at the end, the data, it's pretty much the most important part. So subject to the client's requirement or the type of data that you want to collect, it's the sensor that is the key. So as mentioned, whatever data that our clients are in need of obtaining, whether it's thermal imaging, multispectral imaging, we'll be using the suitable sensor involved. So there are a lot. So we're talking about RGB camera for standard imagery, LiDAR, we're talking about multispectrals, hyperspectral night vision, thermals. I'm pretty sure you guys are familiar with some of these sensors that I've mentioned. LiDAR, this is a big thing, especially in surveying for construction industries. To get that millimeter accuracy. But the key is, once having collected the information, that's where you extract key value out of it through the processing stage. We process the information using reality mesh, 3D point cloud imagery. So that's what enables our clients to retrieve a lot of value. So I'm going to give you a sample demonstration, a video. So this is basically the project construction highway in Sarawak. The government there have commissioned the construction of 830-kilometer highway. But the problem for them is actually to monitor the progress of the construction without them being on site themselves. Because you see contractors that are paid based on progress, but not very honest when it comes to how much has been done. So this is where we come in. We go to site, fly our drones, capture the data, and we upload information on our system. So with this platform, our clients, the government, can already view the progress of the construction without them actually being on site themselves. So, ladies and gentlemen, imagine the entire 4-year life cycle information of the construction of this highway will be accessible on our client's archive. So at any point of the construction phase, the clients would like to view, they can easily just go back to the historical records and monitor the information at hand. So basically, other features that you enable, of course, since you guys are in surveying, is overlaying construction drawing plans, as you see on the screen. So with this feature, it enables the site workers to be best assured whatever they're building on ground is exactly according to plan. So let's say 5 to 10 kilometers ahead, there's an issue. So they can anticipate it much earlier and avoid making such errors. So thereby saving in terms of avoiding time overrun, cost overrun, and also benefiting in terms of higher productivity gains. Of course, talking about this type of data and being able to overlay the consultant drawings, the site work, you would require high levels of accuracy and precision. So ground control points and other equipments are needed to be deployed in order for you to maintain that level of accuracy. But of course, talking about the data or the mapping, this is not something that is limited for highways. It can be, if you use your creativity, you want to implement it, let's say to MRT, LRT, oil and gas pipeline inspection, telecommunication line inspection, so on and so forth. So it's also possible. So because at the end of the day, the drone is just a flying object. UAVs, unmanned aerial vehicles. It's the combination of the sensors, the ground control systems, and everything combined, and the processing and the analytics, which gives clients or industries the data information for them to analyze or to make a full value. Okay, so I guess this is just pretty much about drones. The next technology that we will be covering is virtual reality. Basically, VR, this is a simulation, effectively something, computer technology simulating an environment, a physical environment where users will use it in order for them to be immersed and interact within that 3D world for whatever objective, whether it's for marketing, whether for gaming, or even medical purposes, for military, etc., etc. So, as mentioned, VR equally to drones would constitute the IR 4.0 technologies, and yes, the use cases are steadily being expanded as we speak. There are new use cases as well. While technology is evolving, new things are being made possible currently, in which several decades were not possible in that sense. Nevertheless, for VR, in the next slide, I would like to know that the application are many as well. Beyond advancement in surveying, it's heavily used in machining and production, the processes of design, education, for collaboration, because in terms of visualization, communication, VR is something that adds tremendous value for clients to be able to use and to work in a team in a collaborated manner. So beyond that, the applications we are talking about, factory, in medicine, as mentioned, military, tourism, it's something that adds a lot of value, tremendous value in that regards. Because as I've mentioned, VR is essentially creating a realistic three-dimensional image. So with this simulation of an artificial environment, users to essentially tap into an imaginary world for, as I've mentioned, for training, for communication, promotion purposes. So the applications are endless. However, VR itself, there are many breakdowns or components of VR as how the extent you want to go into the depth. Because certain VR, they are only, basic VR is only using a mounted head display. So basically it just affects your visuals. However, there are other forms of VR that involve touch and haptic interfaces, or your touch sensories. This is something beyond. We're talking about 4D VR in terms of smell, in terms of your environment shaking according to the visuals that you are seeing. That goes beyond incorporating the auditory and visuals, which is standard, the sound effects and the visuals that you see. So in that regards, VR can have several layers as to how do you call it, deep or how advanced your VR experience for the user is intended for. Talking about medicine, of course, you would require the touch or the haptic interface experience. However, when you're talking about, let's say, movies or gaming, a head-mounted display, I mean, visuals suffices compared to the more elaborate training that medical doctors would require in that simulated environment. So in terms of the components of VR, I'm sorry. There are many. So from the lenses, the screen display, the processing unit for the 3D visuals, and also sensors. It can come in the form of gyroscope, accelerometer, magnetometer. You know, gyroscopes, like to get a balance of the user situated at the headgear, for it to know where the person is actually looking, and for it to appropriately conduct the environment based on the angle of the user's angle of sight lah. So for the next slide, so those are the specific attributes. I'm going to cover you a little chronological order of virtual reality. So as I've mentioned, drones came somewhere around 1980s, but VR came actually much earlier, in 1960s, although it only came in a conceptualized form or a theoretical manner without any real-world application. So in 1962, a filmmaker actually had that idea of virtual reality, incorporating it in his audience's experience in watching a movie. However, only 6 years after that, the first computer headgear, a successful VR headgear, which was called the Sword of Damocles, was invented by an MIT computer researcher called Ivan Sutherland. So Ivan Sutherland is considered the father of VR displays. So the Sword of Damocles, as you can imagine back then, the headgear was quite bulky, very big, very inefficient, but irregardless, it still set the motion because people already had the idea, the concept of how a VR would manifest itself. So fast forward several years later, the word VR was coined, and also the application was steadily being implemented during the 80s and the 70s, so on and so forth. And of course, Google, a big player, came in when they actually started off with developing their VR goggles. Also, Oculus Rift came in developing their own product, later on to be acquired by Facebook. But of course, VR steadily, the inception was in movies, but the gaming industry really did a lot of favors, benefit to the VR industry, as it pretty much just exponentially exploded into other realms as well, talking about military, medical, even industry for inspection purposes, asset management, etc., etc. So that's pretty much just a short chronology of virtual reality. So in the next slide, though I must say the industry is still steadily growing. So the types of virtual reality: non-immersive, semi-immersive, fully immersive. So as I've mentioned previously, the types of in-depth VR experience that you want to experience. So for the next slide, the application, the sectors, you notice for VR specifically, and AR in that respect can include, but not limited to, real estate, entertainment, robotics, in astronomy, space exploration, health and safety purposes, artists' purposes, education, and mass surveillance. So you notice on the far on the right, this is a breakdown of the industry currently. Blue represents AR and green represents VR. So this is the market size estimation. So specifically in terms of the headgears or the equipment for each respective technologies that are being sold since early 2016 up to 2020 and onwards. So you can see that the industry for augmented reality is reaching around 50 billion, and for VR respectively it has reached somewhere around 20 billion US dollars, which is considerably sizable in that respect. Although I must emphasize that when it comes to the high-end electronics market, which includes smartphones, which includes iPads, Fitbits, smart wearables like the smart watches, VR and AR headsets are still considered a small portion. However, it is steadily increasing in that regards. So we still can have a lookout in case for the growth potential of these various sectors. So in the next slide, we are coming into augmented reality. So forget for a moment VR. We will show you a video, a demo for VR momentarily later on. But just to cover a little bit about augmented reality for you first, so you don't lose any attention. Because you note that virtual reality and augmented reality, as you can imagine, they have commonalities between them in that they are essentially interlinked. But of course, they have some considerable distinction between them, which is pretty much self-evident. I'm pretty sure the students here are quite aware of that. So in terms of AR, beyond not using a headset like VR does, AR usually typically can just use a smartphone device or even an iPad. So AR is an experience. It's similar to VR in that it creates a simulation, a 3D simulation. However, other than actually creating a whole physical environment, it actually combines two worlds, as in the real world environment, where it superimposes a computer-generated simulation. So for purposes like education, for purposes such as presentation, marketing, etc., even gaming. So the technology has been widely popularized by Pokemon Go in 2016. Before that, of course, AR has existed as well. But similarly, like VR, it was the gaming industry that really took AR and launched it to a rapid pace. For in the next slide, just to cover with you a little bit about the sectors. Similar with VR, it covers tourism, medical, entertainment, flight training, education. Well, education covers all medical, flight training. This is part and parcel of the education experiences, training experiences, and talent upskilling for the various sectors. It's also for marketing purposes in retail, for industrial design. It's mostly for inspection, for quality control, so on and so forth. So the high penetration of smartphones, actually, as I've mentioned, smartphone is one of the high-end consumer markets, the product of the high-end consumer market, a large segment of it, because as we all know, we all have smartphones. And so the high penetration of smartphones actually indirectly benefited AR. So you notice in the few back slides, AR is actually larger in size than VR. And one of the reasons probably is because of this, because the high usage, the high volume of smartphone usage amongst people. That enabled AR to be and easily downloadable compared to VR, which requires headsets and other complicated headgear. Whereas in AR, and every one of us here has a smartphone, most of us, an iPad. So that's something already straight off the bat you can use immediately once you've downloaded on your respective Google Store or iPhone, Apple Store. In the next slide, the applications in augmented reality are many. The components, though I've mentioned, it only requires as much as a smartphone or an iPad. Of course, there are also other deeper applications of AR. For example, smart glasses. So this is something that Google has also tried using. So the key components, including the processing unit similar to VRs, also the projection screen, also the sensors and the cameras. Google came up with that Google Glasses, which heavily incorporated AR features. But unfortunately, the marketing or the execution of the product was not as fantastic as the iPhone was back in 2008. So unfortunately, we do not really see the Google Smart Glasses being a trend, such a mainstream trend as you would like it to see. But nevertheless, still a minor setback. I still believe that in the future, it will come in the right timing with the right technology. Let's say 5G, edge processing technology also comes. That actually would enable augmented reality experience to be taken to a whole new level, and also the smart wearables to be something much more practical in everyday life. In the next slide, the chronology of augmented reality. So basically, augmented reality came even earlier than virtual reality. This is in 1901. So the idea of electronic displays was actually pushed forward by this French author, Frank Baum. Of course, this concept has been pretty much displayed around by the people in academia, in fiction, in story writing. But it took about nearly a century actually before scientists in laboratories actually had a working prototype. Boeing actually first coined the term, and the first functioning AR system came about the same time in 1992. Of course, this is much after VR. If you remember, VR had a functioning prototype in the early 60s. Augmented reality, however, is a little bit more difficult because, as you can imagine, superimposing a computer-generated simulation to a real-world environment, that's something that's more difficult to achieve, harder than it sounds. But of course, the application, while it was further refined and developed and further perfected, it was used in military predominantly, and of course, gaming couldn't help itself but took it and also played around. Google actually in 2013 came up with the concept smart glasses. In 2016, it had the other version, of course, but AR in that manner was more popularized in 2016 when Pokemon Go actually came into the mainstream market. I'm pretty sure you guys know Pokemon Go, right? It's a big game. So 2016 pretty much was a good timing because that's where the Y generation, my age category, those who grew up on the Pokemon Pokemon movie or anime, actually they grew up to age nicely around 20, mid-20s, and that's when the game Pokemon Go actually came out. So that actually resuscitated or jump-started the trend, the phenomenon, the Pokemon phenomenon. Although only to a brief period, as you imagine, it was a hype. For 1-2 years, you saw people going around all of KL, Subang, Selangor, walking with their phones, like playing Pokemon Go. So it was an interesting time. But of course, there are other sectors that saw the value in AR and took it and being implemented currently. So the function has been expanded beyond that area as well. So for the next slide. So I'm going to give you a demo for augmented reality. So for our case specifically, as I've mentioned, we are in heavy industries. So we cater to various engineering, intelligent industrial applications, oil and gas, construction, real estate. So what we do with AR, the combination of all the technologies. The first is data collection. So you want to create a computer-generated simulation, whether it's purely designed, animated from scratch, or it's a reality version, captured version, stitched into AR format. So using drones, you fly a drone and you capture your information. So using photogrammetry, you see the skies in front of you changing, yes? So using photogrammetry, using the captured image. So what you see in front of you is the office. So we will render the information, the image stitched, image captured by drones and stitching it into an AR form. So you see the room, Mr. Army is walking left and right. So this is me, I'm sitting down doing the presentation. So you see Menara TM. So it popped up and it's now in front of the table. So from far away, the building looks clean, yeah? But upon further examination using our drones, it's not as clean or as tip-top condition as you might expect. So the drones captured the image. So whatever you see in front of you is exactly according to the building on site. So this is for insurance purposes. They want to inspect the condition of a building. They want to monitor whether of any asset defects, for maintenance purposes, etc., etc. But the key is anything that can be captured using drones can be stitched stitched into an AR. So in this particular example is a castle building in Romania. So Romania is a land of Dracula. So they want to repurpose the entire castle area and develop a tourist spot. So before refurbishing, they want to capture the information, the existing building, and have it saved on archive. So similar concept for preservation purposes, tourism, for archive, you capture using drones. And with the information that you've stitched, you produce an AR model, as you see in front of the screen. So basically, this can be achieved using just a smartphone camera or even an iPad device. So imagine no need the hassle for complicated headgear for you to actually visualize. So other functions is for Demang. So we fly around and capture location for tourism. So we can even incorporate details, information, make it gaming, like interactive. The display historical information of that particular subject, etc., etc. And also for perhaps inspection. Maybe. Okay, before that, Highland Tower. You guys are kids, right? You guys love scary stuff. So probably this is Highland Tower. For those who don't know, this unfortunately several decades there has been a tragedy that transpired. So there has been numerous casualties. So the place has been abandoned. So there are no residences around the premise. So basically, about due time, the place is about to be demolished, and they want to build a new residential area, commercial, whatever it may. But the area actually attracted considerable amount of rumors that the place is haunted or ghosts reside within the vicinity. So we couldn't help ourselves, just went to the area, flew drones, captured, and we can guarantee that there are no ghosts within the area. But yes, the purpose of this, what we did was just for archive before they demolished the area, where we wanted to actually have something on record. So for augmented reality, imagine, I mean, now it's COVID era, right? You cannot go to any place without having to scan your QR code and inputting your detailed information. So now imagine a QR code. Let's say at the airport, a tourist lands by and he wants to know which popular tourist site needs to be visited. So there's a QR code, a recommendation. The tourist he scans and pops out interesting place, let's say Langkawi or apa seronok kat Malaysia, shopping malls, anything. Okay, but in this example, this is Balai Polis Berhantu. Balai Polis kat Gombak Lama, if you guys are familiar. UIA, budak-budak UIA tahu kan. Tapi for budak UM ni, kononnya this place is also haunted. UM, okay. Budak UM, I guess you guys know. So we went there. So we can this is the outside, how it looks like outside. So let's go inside just to see a better feel. This place has been abandoned, but you notice it has been used for illegal activities for drug addicts. You can see all the illegal paraphernalia. So kids, stay away from drugs, not very good. But of course, just to give you a concept of how the technology can be applied. You guys, if you guys like gaming, it helps tremendously. I mean, something that you guys can immediately pick up and just play around with much easily. In fact, I just met this one of my colleagues' son, somewhere around 9 years old. I just showed him some AR stuff, and without me noticing, I already knew how to more in depth, manipulating the data even further. So I could see from then on the new generation are more talented in that respect. So I'm quite confident that the technology, when it does become mainstream in everyday SOPs, a technology application, that you guys will be able to use it much more effectively. And very good that UM is conducting classes just to have you guys exposed for the latest technology out there. So now this is Langkawi, as I mentioned, for tourism, marketing purposes. Langkawi, burung helang, Langkawi, Langawi.
Langkawi.
Langkawi, yes. I'm sorry, my cousin. So saya repeat lah. This is Geo Forest Park. So Kilim, unfortunately this is a very popular tourist site internationally recognized, renowned. Tapi unfortunately sebelah dia, there's an issue where people are illegally dumping trash, all other wastes. So something most unfortunate. So this is what we actually did. We went there and just captured information just to create transparency. To create visibility of how polluted the area has become due to lack of supervision, etc., etc. So now I hope you guys can see the idea So now, okay, for your purposes, this is sekolah in Kedah. So this is sekolah by our former Prime Minister's father. Tun Mahathir's father was a headmaster in Sekolah Sri Iskandar in Kedah. So basically, what we want to do here is they want to refurbish the area. So you see the Semak Samun here. They want to build a new center of excellence. So what we do is we superimpose a computer-generated simulation to the real-world environment. So we delete and erase the Semak and we put the building that we want to build. And henceforth, we can actually imagine the condition of the site or how the output end product would look like. So you can, this is a useful tool for architects, for you guys, for surveyors to actually add value or improve. Use this tool to improve your existing operations or your current workflow in that respect. Of course, since we are in the industry, a lot of customer re-education is required. We have to teach, knock on our clients' doors and teach them of what is currently available, because most clients, there's a stereotype that it will cost a lot of money, but disruptive technology implies that it's disruptive, it's cost effective, very efficient, highly accurate, so on and so forth. So in the case that you see in front of you is Alostar, Panda Alostar. So we've captured it and we've formulated it into an AR form. So in this case, we want to give it to Menteri Besar or the Member Parliament just to show their rakyat lah, that they are doing something, that they are in touch with the latest technology. So of course, I want you to understand that privacy, security when it comes to drones is quite scary lah. That's one issue. Hence why I mentioned previously in the first two slides that drones, when the technology existed quite a while, but it took a while before it was widely implemented in commercial applications, specifically due to the reasons privacy, security lah. People are afraid of the extent of information being leaked, of how people's privacy can be actually made public by third-party irresponsible people, etc., etc. So that's why agencies such as Department of Civil Aviation, JUPAM, Jabatan Pemetaan, they require permits and licenses to be applied for before any flight operations are being conducted. So you see in front of you is for Bandar Shah Alam. So all the demonstrations that I am showing you, these are all for commercial applications for the various sectors that I've mentioned, for tourism, insurance, real estate, construction, oil and gas. So for the various purposes that I have, that we have discussed, gone through, for training, for marketing, for team discussions, so on and so forth. So Ami ada VR nak tunjuk. So for VR demonstration, so for VR, VR is slightly different, but well, it's similar concept as I've mentioned, they're interlinked, but it's more sensory inclusive lah. So it takes multiple forms of our 5 senses. In that regards, so jangan nak pasang headgear.
While waiting too.
Yeah.
I would like to ask, what's the difference between the use of drone imaging as compared to 3D laser scanning, yang the bigger machine they use kan? But I think the outputs of the images tu macam about accurate lah from what I see lah from your presentation kan. So what are the difference between these two technologies?
Very good question, Doctor. So basically, previously I mentioned that the drone is just a flying object. So it's whatever the sensor it is that you use and the data that it is that you want to require. So for the sample that we showed, this is basic photogrammetry lah. Ami dah tunjuk VR. I'm trying to explain to them, so nanti dia lose focus. So basically, photogrammetry is the method that we use. So we just stitching random standard pictures, images, 4K camera lah. But for LiDAR, we can easily mount the LiDAR sensor on the drone itself, and we can capture that type of information. So the comparison for industries is in terms of accuracy. As far as concerned, photogrammetry, even using ground control points, what we can actually achieve, the highest is probably 3 centimeters accurate. That is good enough for construction site, for the real estate, but for certain other sectors, they require millimeter accuracy. Of course, then we would be using LiDAR technology, light detection and range. But of course, the price is a factor that comes into play. Because LiDAR is something that is way much more expensive compared to photogrammetry which uses a standard RGB camera. Although if we look at the current market, there are new products out there. DJI, the largest producer of drones, is actually coming up with its own LiDAR technology payload sensor, which is much more cost effective. But at the end of the day, if you ask me, yes, I prefer more LiDAR because that data, if it's inaccurate, is useless. And of course, LiDAR, when it comes to mapping, it's highly accurate. The implementation goes beyond mapping. It's used for even in industrial robotics in terms of self-driving cars. LiDAR is a technology that is highly reliable in that regards. Tapi untuk kita ni kat Malaysia ni, unfortunately, price is a big factor. So hence why we deliver for our clients photogrammetry. Tapi in terms of capacity, yes, we are also capable of producing LiDAR lah. In that regards.
But macam drone imaging ni, they can go into macam internal building ke?
Boleh. It's also a method. Tapi in terms of you saw just now, that was indoor mapping lah. So the camera, we had to mount it on a gimbal, and then kita kena jalan lah, masuk dalam, and then we have to map it, and then we will stitch it using the same processes, the methodology. Aerial, atas-atas, tinggi-tinggi sikit, we will be using a drone. Tapi at the end of the day, notice doctor, that the drone itself is carrying the camera. So it's just a matter of cabut the camera and then
pegang je lah.
Yes, the staff itself pegang. So for your students, if you up for it, habis COVID ke, we are always open to collaborate dengan institutions of higher learning. So we can actually conduct a course for me to show you a demo lah, how the back end is actually done in terms of the 4 pillars.
Yeah, I just wanted to ask about photogrammetry or image processing skills ni kan, where can students learn further.
Yeah, so the students, you should be aware lah, your professor is on right point lah. So the image processing is very key lah for you guys to understand, which has a lot of application benefits in multiple sectors in that regards. So image processing ni tremendous use cases being developed, image processing. Now we are hoping for 5G technology to become widespread. So 5G technology dah ada, we can do image processing in terms of self-driving cars. You know, the cars before they drive, they have to process the environment. So for it to actually know how to navigate or to drive down the roadside lah. So imagine self-driving cars. So now imagine self-driving racing cars. So imagine the edge processing technology that requires to process the images much faster. So this is a new area lah, which is steadily being developed lah. So inshallah Malaysia can be a leader in this area. Inshallah. Okay, thank you. So now I'm going to for the VR demo. Tadi Mr. Army, he will put on the headgear. So I hope you students can imagine yourselves also mounting the Oculus and being redirected into the simulated environment. You guys can see this? Okay, Army?
Yes.
So if you guys, my personal favorite game is Counter-Strike. So imagine if you guys actually simulated your own environment or your dimension. So ni bilik, this is the same balai polis Gombak lama tadi. So AR, now you are inside it. You've created a VR form. I'm sorry, lagging sikit. As I mentioned, it's always subject to the Wi-Fi connection juga. So now imagine you are inside the building. Army sekarang, he's doing the demo. So he's confident currently sebab sekarang pukul 3 petang. Kalau malam-malam, I don't think he'll be able to do it. So now imagine the tremendous applications that can be brought forth with such application. You guys are students, you guys are much more creative than we guys are. So for gaming, for medical, let's say the potential, the surgeon, let's say he's a surgeon in cardiovascular heart bypass transplant, benda-benda kan. But he has a patient in Asia. So he can actually simulate, combining robotics and also VR, he can actually simulate the surgery being done. So at the end of the world, there's a robotics arm simulating his exact micro movements of his hand. And at the end of the world, he's actually conducting the surgery on a dummy. So, and using VR lah for him to visualize what he's currently operating on. So that's something interesting. Or for military, you are imagining yourselves on the battlefield for training purposes. You are combating military combatants to improve your what do you call it? Your accuracy in terms of shooting, rescue and operations, etc., reconnaissance, etc. So in this particular example, is ini Shah Alam yang Amin lupa. Oh, ni Ampang. So basically, note that for VR, another reason why we prefer AR, personally for us, why we prefer augmented reality. Of course, it's easy to be delivered using smartphones, using iPad. But another reason is because VR we recognize that older people, not necessarily old there are young people as well when they put on the headgear, they only pening sikit. They suffer from vertigo. They have issues in actually balancing their body based on the visuals that they are seeing in front of them. So with that, ada issues, some problems happening where they rasa kind of seasick. So it doesn't take them more than 2 minutes or even 1 minute before they can go any further. So that's why we deploy AR. So to prevent people from having that negative user experience. But of course, for young people, that doesn't bring any issue about. VR can, for some people, it's their cup of tea, subject to people's preferences juga at the end of the day. So this is captured using drones, aerial view. So we've stitched it for VR lah. So note as I will mention again that the drone is the acquisition, the collection device. So once you've collected the data, whether it's in the form of images, LiDAR points, it doesn't matter because you stitch it into outputs like reality mesh, 3D point cloud, AR or VR lah. In that sense, but yes, for your purposes, for the students in surveying, accuracy is highly important. It's pivotal. So LiDAR is something that accuracy is very crucial, in which adds more better value than photogrammetry can offer. So give and take, it's a trade-off between our client's requirement, their ability to spend, and also the subject or the data that they like to require. So basically, that would be it for the presentation. I've covered the essentials of the three technologies: drones, VR, and AR. So in the context of surveying and other applications, sector applications,